Hey, so we're back with example 2 in the notes for exponential functions, and we're given the equation y equals 2 times 3 to the quantity x plus 1 and then minus 4. So the parent function is y equals 3 to the x power. Okay, that's my base of 3. Then that base, since it's greater than 1, means that this is an exponential growth function. So its slope is going to start out shallow and then get steeper, steeper, steeper in that J-curve. The equation of the horizontal asymptote is always y equals k, and the k in this equation is equal to negative 4. So we can come over here to negative 4 on the graph and dash in that horizontal asymptote. Okay, then the anchor points that we're going to use to transform this graph is the 0, 1, the y-intercept, that's always the same, then 1, b, and our b is equal to 3. So let's go ahead and up here we'll just identify each of those variables. So the a in this equation is positive 2. My b, the base, is 3. Then h is negative 1 since we're going to the left, and the k is equal to negative 4. So my anchor point 1, b is 1, 3, and then negative 1 reciprocal of b, so the reciprocal of b is 1/3. Okay, now I'm going to multiply the y value by a, and that will take care of any vertical stretch or reflection in the x-axis that's occurred. So when I multiply the y value by 2, my x stays the same, and 1 times 2 is 2. Then when I multiply the y value here, 1 stays the same, and 3 times 2 is 6. Then I multiply the y value by 2 in this last point, the x stays the same, and 2 times 1/3 is 2/3. Okay, next we're going to add h, which is negative 1, to the x coordinate. So 0 plus negative 1 is negative 1, and then the y stays the same. Okay, then 1 plus negative 1 is 0, and the y stays the same. Then negative 1 plus negative 1 is negative 2, and the y stays the same. Okay, then we have to add k to the y value. So we're going to take our k, which is negative 4, and we're going to leave the x the same, and then 2 plus negative 4 is negative 2. Then we have 0, which stays the same, and then 6 plus negative 4 is positive 2. And then negative 2 stays the same, and then 2/3 plus negative 4 is negative 10/3. Okay, so we're going to go ahead and plot those transformed coordinates on our graph. So we'll come over here to negative 1 and then down to, okay, the point 0, 2 is our y-intercept. And then negative 2, negative 10/3 is negative 2, and then negative 3 1/3. And we can see here how the curve is going to come along this horizontal asymptote, bend to turn through these anchor points, but I don't know how steep I should come up as I come across that y-axis. So I'm going to pick an extra guide point. I know negative 2, negative 1, 0, so the next choice that makes sense would be a positive 1. So I'm going to evaluate my function by substituting in a 1. So 2 times 3, and then that's to the 1 plus 1 power minus 4. Okay, 3 to the 1 plus 1 power would be 3 squared, which is 9. And then 2 times 9 is 18. And 18 minus 4 is 14. So the point 1, 14 is going to be on this graph. Okay, so then to sketch the function, we're going to start along this horizontal asymptote, turn through these 3 transformed anchor points, and then I'm going to have a heck of a time making a straight line there. So I'm going to just cheat a little bit here and pass through. There we go. And that will be my exponential function. So the domain of this function, the domain of all exponential functions, is all real numbers. So negative infinity to positive infinity. And then the range, our horizontal asymptote is here at -4, and we're going up from there. There's been no reflection in the x-axis, so starting at -4 and then heading up to positive infinity. Okay, so go ahead and try this problem on some scratch paper or on your whiteboard if you have one. And you're going to determine first what is the parent function, then is it growth or decay, identify the horizontal asymptote. You're going to do the table in order to transform the anchor points, and then find 2 extra guide points when x is 6 and 7, sketch the graph, and then identify the domain and range. And when you're all finished with that, you can turn the video back on and we'll go over those answers together. So the parent function is not including the negative. Okay, the a in the front here is what that negative value is. So the a is equal to -1. Okay, the base is the value directly affected by that exponent, and that would be the b. So the base here is 2. Then the h, since this is x minus h, our h is a positive 3. And then the k is here at the end, and that is a positive 5. So our parent function is 2 to x, which 2 is greater than 1, so that is a growth function. Okay, the horizontal asymptote is k, and our k is 5, so y equals 5. Then the anchor points of the parent graph always have a y-intercept of 0, 1, then the point 1, comma b, which would be a 2, and then -1 reciprocal of b, and the reciprocal of 2 is 1/2. Next, we're going to multiply the y values of each of those coordinates by the a, which is -1. So we'll have 0 times 1 is -1. Then 1 comma 2 times -1 is -2. Then -1 comma, and then 1/2 times -1 is -1/2. Okay, then we're going to add the h, and our h here is a positive 3 to each of those x values. So 0 plus 3 is 3 comma -1. And 1 plus 3 is 4 comma -2, and -1 plus 3 is a 2 comma -1/2. Then the k is 5. We add that to y values to translate the graph up 5. The x stays the same, so 3 comma and then -1 plus 5 is 4. 4 comma and -2 plus 5 is 3. and then 2 comma negative 1/2 plus 5 is 9/2. And we are going to sketch those points, and then we'll need some extra guide points. When we evaluate 6, negative 2 raised to the 6 minus 3 power plus 5 is a negative 3. And when we evaluate 7, negative 2 to the 7 minus 3 plus 5 is negative 11. So we sketch those points on the graph and then plot our asymptote, and the curve then comes down through those guide points and the transformed anchor points. The domain is all real numbers, and the range, because we've had a reflection in the x-axis, the range now is starting at negative infinity and heading up to that horizontal asymptote at 5, non-inclusive.